Precision agriculture. It is the management of spatial and temporal variability in the use of agricultural inputs to increase economic returns and reduce environmental impacts. Spatial variability is the variation found in soil, terrain, and crop properties across an area at a given time. For example, soil pH and crop yield is not the same in every part of a field. Temporal variability is the variation in soil and crop properties within a field at different moments in time. For example, the difference in yield maps from one season to the next, or changes in soil organic carbon. There are many factors that contribute to the spatial and temporal variability within a field. Soil characteristics such as pH, soil organic matter, texture, water, etc. Terrain, namely slope and aspect. Management practices, for example crop rotations, reduce till or control traffic farming, etc. Environmental factors include weather, weed, insects, and diseases. Data can be collected in different ways. Imaging crops and soil from satellites and unmanned aerial vehicles, better known as drones. While satellites are able to provide data for large areas and in a number of portions of the electromagnetic spectrum, sensors installed on drones produce images of high level of details. Defining locations by using global navigation satellite systems such as the US GPS or EU's Galileo, and measuring characteristics of crops, soil, and weather with field sensors. Multispectral images from satellites and drones are mainly used to calculate vegetation indices for crop monitoring. The most known is the Normalized Difference Vegetation Index, NDVI. The vegetation indices provide information on biophysical properties of crops, such as biomass, water content, chlorophyll content, etc. This information describes the crop state and health. Ground sensors can also be used to get even better precision data. The information helps farmers to detect crop stress of various origins such as deficiency of nutrients or a disease even before it is visible in the field and react promptly. Vegetation indices from satellite and drone data can identify crop stress caused by the lack of water. Farmers can also install soil moisture sensors in the fields to receive even more precise information on the plant's need for water and to optimize irrigation. Maps from satellites or drones and from ground sensors can show spatial variability of crop and soil characteristics within the field. Time series of such maps provides information on seasonal variability and long-term trends. Proper analysis can determine the causes of the variability and optimal management response. For example, zones of the field that show long-term lower productivity need to be managed differently. Maps of spatial variability are essential for optimal use of fertilizers and chemicals. For example, the need for nitrogen is higher in some parts of the fields and lower in the others. The farmer needs proper equipment for variable rate application and GNSS device in the tractor to precisely locate the real-time position and release the optimal amount of fertilizers or chemicals. This technology can save a significant amount of resources. Such applications serve farmers as gateways to the data and information they need to apply precision agriculture. The data is presented usually through maps and graphs and can be easily downloaded to be used in devices for optimization of the applications of resources, fertilizers, chemicals, water, etc. More functionalities that enable farmers to keep records of activities and resources expand the solutions to comprehensive farm management systems.